Let's solve problem 4.41 for Microelectronic Circuits 8th edition by Sedra and Smith. So we have four circuits that we're going to work through, and we're going to use the constant voltage drop model, where the voltage drop across the diode is 0.7 volts, and we want to find the voltages and currents indicated. So when we're starting with the circuit analysis problem with the diode, the first thing we want to determine is the diode on or off? Is it forward biased or reverse biased? So this diode, it usually conducts current and it has a voltage drop. Here it's 0.7 volts. And we see from this model, we're going from 5 volts observed from the anode and negative 5 volts observed from the cathode. So we're going from high to low, 5 to negative 5. Therefore, this diode is forward biased, which means VD is equal to 0.7 volts, as we already said here. Now we can calculate this voltage point here at V, because if we know that this is negative 5 volts, then if we travel up the circuit, we had a drop of 0.7 volts here. We can calculate V equals negative 5 volts, and then just add that voltage drop back of 0.7 volts. We get negative 4.3 volts. Now we can calculate the current using just KVL. And since it's the current across this diode, we're going to be doing the voltage at the diode, which we just calculated, right? Because it's just this point here, V. So it'll be 5 volts minus negative 4.3 volts divided by the resistance of 10 kilo ohms. That's equal to 0.93 milliamps. All right, let's move on to the next circuit. All right, let's solve circuit B. So again, same setup here. You would expect 0.7 volts to drop. But first, let's examine the diode. So from the anode's perspective, we see negative 5 volts. And from the cathode perspective, we see plus 5 volts. So this time we're going from negative 5 to 5, low to high. Because of that, the diode is going to be reverse biased. Now, when you hear reverse biased, you can immediately state that the current is 0. Right? It's just one wire. This diode is going to behave like a giant resistance, basically infinite resistance, because it's behaving like an open circuit. So no current can travel through here. And if we use that principle to calculate voltage, right, where V equals IR, so if we're traveling down, it would be 5 volts minus IR, which is equal to 5 volts minus I0 times 10 kilo ohms. So that's just 0, right? So we just get left with 5 volts. And then another way you can think of it is because the diode acts like an open circuit, it is consuming the entire 10 volt drop from 5 volts to negative 5 volts. And because the voltage label here comes before the diode, we still see that 5 volts before it all gets dropped here. Let's move on to the next circuit. Okay, let's solve circuit C. Same principle. Voltage drop should be 0.7 volts. And let's analyze the anode and cathode of this diode. The anode observes 5 volts and the cathode observes negative 5 volts. So this is going from high to low, 5 to negative 5. Therefore, this will be forward biased. So we will conduct some current through this diode. The voltage drop across the diode will be 0.7 volts. So knowing that, we should immediately be able to calculate for V, right? will be 5 minus 0.7 volts equals 4.3 volts. Now, what about the current? Well, it's the same idea as part A. We're starting with the current here at the diode, and then dropping down all the way to this -5. So I is equal to 4.3 volts minus -5 volts divided by 10 kilo ohms. And that is equal to 0.93 milliamps, just like part A. Again, because the current starts at the diode, we're going to begin our calculation at the diode, where the voltage drop has already occurred, which is why we start at 4.3 volts. All right, time for the last circuit. All right, let's take a look at this last circuit. So, just like always, we start by analyzing the anode and cathode. See that the anode has an observation of -5 volts, and the cathode has a positive 5 volt observation. Therefore, we're going from low to high, -5 to 5. So this diode will be reverse biased. So once again, as soon as you read reverse biased, you can immediately state that the current across the diode will be 0 because it's behaving like an open circuit with infinite resistance. So we can look here, right? If we travel up from the circuit to calculate the voltage at V, it would be -5 plus the voltage drop across the resistor, which is equal to IR. So it's -5 volts plus 0 times 10 kilo ohms, which is just 0. So therefore V is equal to -5 volts. And again, another way to look at this is because the diode has infinite resistance, it will consume the entire voltage drop from 5 to -5. It will consume all 10 volts of that drop. And because this V falls after the diode, it will be observing the voltage after the diode consumes all of the voltage drop, which is why it is -5 volts.